Hello, everyone. I wanted to talk to you about a new theory that I have personally about some reasons for the Mandela Effect. And it's a theory of quantum, or well, an interpretation, I should say, of quantum mechanics called transactional interpretation. And Ruth Kastner, this is her website, transactionalinterpretation.org, and she has written a book with the father of this interpretation, John Kramer. And she has kind of a neat thing that I like, which I've seen this before, but this paragraph says it pretty eloquently, so I wanted to share it with you. Okay, this is a a projection of a tesseract into 3 dimensions, because we obviously we don't see in 4 dimensions, so we don't know exactly, but that's how it would look in 3 dimensions. So you see the little cube in the center. Figuratively speaking, that represents your wetware brain, but yourself, including your mind, both preconscious and conscious, is the entire structure. So we can think of the mental aspects of yourself as everything beyond the central cube. Topologically, everything is connected, even though the connections are not by way of the usual classical fields. In this situation, the brain part of you might not be conscious enough to be able to signal to an experimenter that you're aware of something, but other aspects of yourself may be quite busy attending to other issues that cannot be represented at the 3D level. In other words, behavior that the experimenter will record as subject not conscious might actually mean, well, the subject's attention is just elsewhere. Okay, so that's kind of my theory, is that, that we perhaps could be conscious of our experiment or our test that's going on, but other people who don't see the Mandela effect are either A, not conscious, or robots or AI or whatever, or their attention is just elsewhere. Okay, so if you look at how this is kind of neat, this is how the tesseract kind of folds up on itself, and this is a net of a tesseract in this shape of this crosshair. Okay, and this is kind of neat too, because this also, I think, is what's happening with crop circles, is that they're coming down in a different dimension and we're seeing it in our 3rd dimension. Okay, but in looking at this, first a point that's going to come up here in just a second is in 0 dimensions. A line is 1-dimensional. Square is 2-dimensional. Cube is 3-dimensional. And tesseract is 4 dimensions. Okay, so kind of neat. Okay, now going to the theory. Well, first of all, let's go to the author of the theory. Or, I keep saying theory, but I really mean interpretation. Sorry about that. Okay, he got his PhD in physics from Rice in 1961, and he has worked at the Relativistic Heavy Ion Collider at Brookhaven and also CERN in Geneva. So you might have something to say about quantum physics, I would think. Okay, so what he's done is he has taken the psi wave function of the standard quantum formalism to be retarded. Now that just means normal, okay? And it means normal going forward in time, and advanced backward in time waves that form a quantum interaction as a Wheeler-Feynman handshake or transaction. Okay, and he introduced this in 1986. And he's also written a fiction book that has some of this theory, interpretation, in Einstein's Bridge, and I definitely want to read that at some point. Okay, so in TIQM, the source emits a usual retarded wave forward in time, but it also emits an advanced wave backward in time. Furthermore, the receiver or absorber, who is later in time, also emits an advanced wave backward in time and a retarded wave forward in time. A quantum event occurs when a handshake exchange of advanced and retarded waves triggers the formation of a transaction in which energy, momentum, angular momentum, etc. are transferred. The quantum mechanism behind the transaction formation has been demonstrated explicitly in the case of a photon transfer. In this interpretation, the collapse of the wave function does not happen at any specific point in time, but is atemporal, and I think that's kind of important, and occurs along the whole transaction, and the emission-absorption process is time-symmetric. Okay, just that means going, they're going to cancel each other out, basically. The waves are seen as physically real rather than a mere mathematical device to record the observer's knowledge, as in some other interpretations of quantum mechanics. And this is the woman's website that we were at, argues that the waves exist as possibilities outside of physical space-time, and that therefore it is necessary to accept such possibilities as part of our reality. Okay, so let's go to some of these equations, and they're not hard. And remember, John Cramer got this from Feynman and Wheeler, and hopefully a lot of you know who Richard Feynman was. He's a very famous physicist. Okay, so they wanted to get something that was that would result in causal and then not into an anti-causal wave situation. Okay, and they came up with it in a very simple and elegant way. They considered all the charged particles emitters present in our universe and assumed all of them to generate time reversal symmetric waves. And so that resulting field is this, where you sum up the retarded waves with respect to time and the advanced waves with respect to time. This segment just means you're summing them all up, okay? And then you would divide that by 2 to get the sum of those. Okay, but also so that it wouldn't be, so that it so that they would cancel each other out, you would also do the retarded waves minus the advanced waves, because remember the retarded are going forward in time, the advanced are going back in time, so you would plus minus divided by 2, and that should equal 0 to cancel each other out. Okay, then that means that and then that was a solution to a Maxwell equation, and it was used to obtain the total field, and they're basically adding these two together, okay, and it ends up being just a summation of the forward waves in time. Okay, and let's see how they got that. You've got the positive advanced waves here, and you're gonna subtract. You know, if you have a plus and a minus, they cancel each other out, right? So chook, chook. So then you're gonna have 2 of the retarded waves, because 1 plus 1 is 2, and then all over 2. 2 over 2 is 1, so therefore you get the retarded or normal waves with respect to time. The total field is retarded, normal, in other words, and causality is not violated. That means that theoretically, and that's important, theoretically you should be just going forward in time, and you shouldn't have multiple things going on, and there should be a consistency of history there. Okay. However, I found this interview with John Cramer, and let's see, where do I need to get to it? Shoot. I think it was here.
Of forbidding retrocausal processes and the normal
Let me
way
back
of
up.
saying things.
When you say there's a problem with causality, what you're not saying that causality is a law that only causal things can happen, are you?
I'm saying that if you want, let's see how to say this. If you want if you want to preserve normal causality in the context of the transactional interpretation, you have to say that certain things are allowed and other things are not allowed. In handshake takes place, there's no residual advanced effects that are left over that allow you to send backwards in time messages. That's not implicit in the formalism, but it's something that you sort of have to put in by hand if you want to get ordinary causality. And as far as I'm concerned, it's something that should be experimentally tested.
Yeah.
Okay, so that was kind of important because he said, first of all, he said, did you catch it, that there shouldn't be any residual, that it had to be done possibly manually, and that it should be experimentally tested. Okay, so let's listen to that again.
That after the handshake takes place, there's no residual advanced effects that are left over that allow you to send backwards in time messages. That's not implicit in the formalism, but it's something that you sort of have to put in by hand if you want to get ordinary causality. And as far as I'm concerned, it's something that should be experimentally tested.
Yeah.
Okay, so so the emitter is doing the retarded waves, giving them to the absorber. The absorber is taking them back in time, back to the emitter. Okay, and theoretically these have to be the same, like what I showed you in those equations. Okay, but what if something gets out of whack? What if there's an anomaly of some sort? Okay, that means that all this stuff in the middle is going to be out of whack if one thing is not, if the retarded waves are in any way, like speed or momentum or any way different, if the retarded waves are different than the advanced waves, all this is going to be screwed up. Okay, so I think that, and an interesting point to note too is I've heard people posit that perhaps there's D waves in other worlds, and that would mean like if you know one was the emitter and one was the absorber, and they were actually communicating back and forth, which I don't know that that has anything to do with that, but I was just putting that out there because I had heard that at one point, and this kind of reminded me of it. But if something gets screwed up, it's gonna screw us up. And so I think that that could be the cause of the Mandela effect, just as a possible thing, one of many, and one that I hadn't really studied before, and I wanted to put that out there. Let me know what you think in the comments, and I hope everyone has a great day. Bye-bye.